If we think about something like 2 third power, we could view this as taking 3 2's and multiplying them together, so 2 times 2 times 2. Or equivalently, we could say, well, this is the same thing as taking a 1 and then multiplying it by 2 3 times. So let's just go with this definition right over here. And this, of course, is going to be equal to 8. Now, what would, based on this definition I just did, what would 2 to the second power be? Well, this would be 1 times 2 twice. So 1 times 2 times 2, which of course would be equal to 4. What would 2 to the first power be? Well, that would be 1, and we would multiply it by 1 2. 1 times 2, which of course is equal to 2. Now let's ask ourselves an interesting question. Based on this definition of what an exponent is, what would 2 to the 0th power be? And I encourage you to just think about that a little bit. If you were the mathematics community, how would you define 2 to the 0 power so it's consistent with everything that we just saw? Well, the way we just talked about it, we just said exponentiation is you start with a 1 and you multiply it by the base 0 times. So we're not going to multiply it by any 2, so we're just going to be left with a 1. So does this make sense that 2 to the 0 power is equal to 1? Well, let's think about it another way. Let's do a different base. That was with 2, but let's say we have, I don't know, let's say we have 3. And I could say, 3 to the 4th power, that's 3 times 3 times 3 times 3, which is going to be equal to 81. Actually, let me just write that down. Let me just write down that this is going to be equal to 81. If I said 3 to the 3rd power, that's 3 times 3 times 3, which is 27. 3 to the 2nd power is equal to 9. 3 to the 1st power is equal to 3. Do you notice a pattern? Every time we decrease the exponent here by 1. So we went 3 to the 4th, and now we go 3 to the 3rd. What happened? What happened to the value? Well, going from 81 to 27, we divided by 3. And that makes sense because we're multiplying by 1 less 3. So we divide by 3 to go from 81 to 27. We divide by 3 again if our exponent goes down by 1. And we divide by 3 again when we go from 9 to 3. Divide by 3. So based on this, what do you think 3 to the 0 power should be? Well, the pattern is every time we decrease our exponent by 1, we divide by the base. And so we should divide by 3 again, would be the logic if we follow that pattern. And so 3 divided by 3, it would get us 1 again. So I know it might seem a little bit counterintuitive that something to the 0th power is going to be equal to 1. But this is how the mathematics community has defined it because it actually makes a lot of sense. Either if you view an exponent as taking a 1 and multiplying it by the base, the exponent number of times, so I'm going to multiply 1 by 2 3 times, or if you just follow this pattern that, look, every time you decrease the exponent by 1, you're going to be dividing by the base. Either of those would get you to the conclusion that 2 to the 0 power is 1, or 3 to the 0 power is 1, or frankly, any number to the 0 power is 1. So any number, so if I have any number, let's say I have some number a to the 0 power, this is going to be equal to 1. Now I have an interesting question for you. And let's just say this is the case when a does not equal 0. I'll leave you a little bit of a puzzle for you to think about. What do you think 0 to the 0th power? What should 0 to the 0 power be? And what's interesting about 0 to the 0 power is you'll get a different answer if you use this technique versus if you use this technique right over here. This technique would actually get you to being 1, while this technique would have you divide by 0, which we don't know how to do. Anyway, I'll leave you there to ponder the mysteries of 0 to the 0th power.